All right, good morning, everybody. Today's Tuesday, April 28th. We are ready to move on to section 2 from section 1. Today's going to seem a little bit weird. I just need to mentally brace you guys and just kind of forewarn you about some of the feelings you're going to feel today. So you're gonna be a little bit confused as to the why, why we're doing what we're doing, okay? But you're also at some point going to realize that the assignment for tomorrow is probably going to be really easy for you, okay? Um, the assignment itself is pretty easy, the work is pretty easy, but the why we're doing what we're doing, why we're stopping to talk about what we're going to talk about today is going to be the part that flusters you just a little bit. I'm going to do my best to try to get you to think back to I don't even know, sixth, seventh grade or something, to help kind of make sense or rationalize how you've already been through this experience before, okay? So what section 2 talks about is what are called natural exponential functions. Section 1 was exponential functions. Okay, now we're talking about natural exponential functions. So when we hear that, it sort of sounds good because oh, good, it'll make sense. It'll be something natural or organic. But that's not what it means or not what it's getting at, okay? What this section is going to focus on is it's going to focus on the natural number. And we expose you guys to this. We see this a little bit in advanced math. So some of this you'll be like, oh yeah, I sort of vaguely remember doing this. But it's going to seem a little bit strange, okay? The natural number is the number E, okay? So again, if when you see that, when you hear that, you might get a little bit of uneasiness because you probably remember hearing that at some point, but not necessarily really remembering what we did with it, okay? What I need you to understand right now is this. E is an irrational number, okay? It's called the natural number E. It is roughly equivalent to 2 point, I got it wrote down here, so bear with me. It's 718,281, 823, and then it just keeps going on. It's an irrational number, which means it never terminates, never repeats. It's just this ugly number. We abbreviate it roughly as E is approximately 2.718. The big thing I need you guys, before I go any further into this, we're going to be working with E a lot today, okay? You're going to be simplifying expressions that involve E. You're going to be evaluating expressions that involve E. You're going to be graphing functions that involve the natural number E. And even though it's going to seem kind of weird, this is kind of that part I wanted to just kind of verify with you guys and help you understand. You've gone through this whole thing before, because the number pi no longer really seems like a foreign idea to you. You guys all know that pi is roughly equivalent to 3.14. It's actually 3.14158 and then a whole bunch of decimals after it. These are very similar numbers in nature. Pi is an irrational number that we actually are very familiar with now, and we know we use it a lot. We use pi almost any time we're dealing with circles and their surface area, volume, anything like that, right? We've become so accustomed and adapt to using the number pi that we no longer see it as this foreign concept. Well, what I need you to understand is that E is basically the same thing. We're going to struggle. In the next part, I'm going to show you where E comes from. It's not really going to help it make a lot more sense, why we use it or anything like that, but at least you kind of get the concept or the idea that we've already gone through this kind of confusion before when we were introduced the very first time to the number pi. But then over the years, the more you work with pi, the more just familiar you get with it. It's the same thing with E, okay? What E is, if we define E, it's a limit, so it's more of a calculus-based concept. It is the limit as x approaches 0 of 1 plus 1 over x all raised to the 1 over x exponent, okay? So what I want you guys to think about is this. If you take a number, and I'm gonna try and show you my calculator. Hopefully you guys can see it all right as I punch buttons in here. If I punch in a number really close to 0, let's go 0.1. If I punch in 0.1 for both of those x's, 1 divided by 0.1 is 10, okay? So this is equivalent to 10. So again, I'm plugging in a number really close to 0. So 1 divided by 0.1 is 10. 10 plus 1 is obviously 11. But now, if I raise 11, hold on one second. All right, let's backtrack here. Hot second. My bad. I copied down the wrong part in the wrong spot. All right, this is supposed to just be an x. 1 plus x. My bad. 1 plus x raised to the 1 over x power. Okay, that was not making sense to me. All right, now let me plug in the 0.1, okay? If I plug in 0.1 now for both of these x's, now it's not 1 over 0.1, it's just 0.1. So this is 1.1 raised to, okay, 1.1 raised to the, and now think about this, this is 1 over that 0.1, so this is 10. If I raise that to the 10th power, I don't know if you can see the screen, it's 2.5937. I'm just going to go to the first two decimal places. 2.59 is pretty close to 2.71, right? So basically, what this is saying is this. If we continue to plug in closer and closer numbers to 0, so if I plugged in 0.01 for both of these x's, this number on my calculator would be even closer to 2.718, okay? So this is where, and like I said before, I'll show you the definition of it, but it's probably not going to help you really understand why we need it any better. This is where E's value comes from. E is the natural number that is equivalent to this limit, 1 plus x raised to the 1 over x power, as x gets infinitely closer to 0. So as you plug in infinitely closer to numbers to 0, your actual value gets closer and closer to this 2.718. That's where E gets its actual value from. Okay, at any rate, here's the thing. It's going to become more obvious and more evident on Thursday when we get to section 3 why it's nice to work with the natural number E. Okay? What you need to understand right now and really grasp hold of is the fact that today's going to be pretty easy, because just like yesterday you were doing things like this, a to the 4th power times a to the 2nd power, or you were doing x to the negative 2 power, and you were simplifying these expressions involving generic bases, a's or x's. Obviously here you just add the exponents. A to the 4th times a to the 2nd becomes a to the 6th. X to the negative 2nd becomes 1 over x to the positive 2nd. The only difference between yesterday and today is yesterday we were using generic bases, and now today we're using E as our base. So like today, it's literally going to be, I think the first 5 questions are this. E to the 4th times e to the 2nd is e to the 6th. That's all you have to do. You don't need to evaluate this. So you don't need to plug in 2.718 raised to the 6th power on the first couple problems. Same thing down here. If you have e to the negative 2nd power, you just write that as 1 over e squared. You don't need to punch this in on your calculator. And by the way, it's worth mentioning, everybody knows where the pi button is on our calculator. The pi button is right here on our calculator, okay? If you look, and I think most all of you have the same type of calculator, if you have calculator issues, you can just Google, where do I find E on whatever kind of calculator you have. If you look directly above this, you guys can probably see this LN button. What you can't see probably on your screen based on looking at my calculator is that behind LN is in blue e to the x power. Just like there's a pi button on your calculator, there is a e raised to an exponent button on your calculator. So all I have to do to get it is go second ln. So if I wanted to evaluate e to the 6th power without actually plugging in 2.718 to the 6th power, all I would have to do is hit second, this ln, it pops up e with a little arrow up, so e raised to the, all I have to do is enter my exponent and hit equals, it's 403.428 with a bunch of decimals after it. Okay, so you guys will all need to make sure that you can find your e to the exponent button on your calculator, because that's going to help you finish off the second and third parts. Okay, the second and third parts, speaking of them, they involve graphing. Okay, the nice thing is, let me count them up for you. Let's see, it looks like 6 of them. 6 of them are matching problems. Okay, so 6 of them, they're going to give you these kinds of functions. They're going to give you something like, I better write it as a function, f of x equals, I'll just show you one of them, e raised to the 2x plus 1 power. So there's going to be a function that looks like this, and then there's going to be a series of graphs that go with it. Well, on the matching problems, it's not bad. All you got to do is plug in an x value. So think about this. When you plug in 0 for x, 2 times 0 is 0, 0 plus 1 is 1. It's e to the first power. All you got to do is punch that in, and you wouldn't even need to, right? What is e to the first power? It's 2.718. Go to your graphs, your matching graphs, and figure out which ones have that point on it, 0, 2.718. If there's more than one that has it, plug in a different x value. X is 1. 2 times 1 is 2. 2 plus 1 is 3. Go to your calculator, do e to the third power. E to the third power is 20.08, so I'm going to round that to 20.1. Figure out which graph has 20.1 paired with x on it. Okay? So that's going to be your next 6 problems. After your first 4 problems are just doing the same stuff we were doing the other day, then you're matching, but you're using e functions. And then unfortunately, the last 4 questions are the ones I'm going to have you just kind of freehand draw a graph, and you're going to have to sketch it, okay? So if we were actually asked to sketch this graph, we would do this same concept. Plug in 0, get 2.718. Plug in 1, get 20.1. So if you think about this, I really don't want to go any further to the right than 1 because my graph is way off there. 0, I'm at 2.718. I'm way up here once I hit 1, so there's that part of the graph. Go back to the left, plug in -1, watch what happens. 2 times -1 is -2. -2 plus 1 is -1. If you raise e to the negative first power, you get 0.367. So I'm going to go 0.4. -1, 0.4 is going to look like this. And we could, if we really wanted to, we could plug in one more number, -2, just to see if it crosses the x-axis. 2 times -2 is -4. -4 plus 1 is -3. If I, one more time, do e to the negative third power, I get 0.04. 0.05 is going to be really close to, but not at 0. So there's what the exponential curve is going to look like. Okay? So again, the work is pretty easy. It's just simplifying expressions involving e, matching e functions to their graph by just picking points, and then actually picking enough points to construct an entire graph on your own. Okay? So that's all there is to it today. We'll get much further into it on Thursday when we get into section 3, but for now it's just kind of refamiliarizing ourselves with using E, and then we'll explain more of the benefits of using E on Thursday. All right, guys, let me know if you have questions on the assignment. I'll shoot you a clarification video tomorrow, and we'll go from there. Have a great day.